Hi, thanks for joining us at today's presentation about augmented and virtual reality with Chauncey. This is one of my favorite presentations because it's just so darn cool. And although I did just ask him how long some of the things he made took him to make, and it took a little while. It took a hot minute. I'm Tassie Gennady, and I'm the host of this series. I'm going to quickly put down some things so I can read. There are other talks in this series coming up. So next week is 3D digitization. So if you want to learn how to make a 3D object or like capture it in 3D, like if you think about the Venus that's in the middle of the fountain out in the middle of the Fine Arts Plaza, we have digitized her in 3D. And you can rotate her all around and look at her, et cetera, et cetera. If you're really ambitious, which we're starting to get, we're going to capture all the fish, and then we're going to put them in a Unity scene, and then maybe you could like steal a fish if you wanted to, if you know that story. After that, we have an advanced media presentation on April 4th, which is all about sort of high dynamic range capture, also really detailed capture, other different ways that advanced media can be useful to you. And then on April 11th, Matt in the back and I will be talking about how to create your own virtual reality tour using Google Poly. And it's not actually super hard, so if that's something that sounds interesting to you. And then finally on the 18th, we're gonna have a hands-on demo, what we call an XR extravaganza, which includes augmented reality, virtual reality, 3D digitization, where you could come and try your hand at some of these things. So, so please feel free to take one of these. They have cool superheroes on the front, just like on my awesome shirt. And if you also have questions, there'll be emails, cyberdh@iu.edu. And then also Chauncey has an email as well so that we can help you with things. Okay, sorry, I'll hand this back to you now that I've like.
Thank you. Okay, thank you, Tassie. This is probably like the fourth time I've done this talk, and it's refined itself and also expanded. There's a lot of videos, so I may kind of skip around with videos. And if there's questions, I mean, you may see me going back in slides to find examples if you guys have questions. 40 slides now, I think. So what's fun about augmented reality and virtual reality is exactly what happened when I was setting up just today. I just set that VR station up, that little laptop, and one student just from out here where I was working said, hey, can I come in and check that out? It's very attractive technology. Okay, so when we're talking about VR and AR in the university, there's like a lot of opportunities for teaching and learning and research. I work specifically in the UITS Advanced Visualization Lab, where we are essentially tasked with assisting all researchers at IU. So one day I'll be working with some folks that are in geology or prosthodontics or the Simon Cancer Center, or even in informatics, anthropology. It's really exciting because day to day it's always different. I'm even helping students build board games and video games and stuff like that. So I go back to being an IU student at IUPUI, and that's where I'm based. So you guys can think of me as an IT guy, but I was originally a grad student that kind of graduated from informatics and then just never left the university. I think it hit 10 years this last January here. There's a lot to do in the educational space and research spaces with virtual reality and augmented reality now that the tools are so accessible and cheap. And that's what I'm going to try to get across to you today as I go through these kind of specific topics here on the goals. So the Advanced Visualization Lab, we started in 1997, and we're sort of a partner group with CyberDH. That's who's hosting this workshop series. Tassie manages that group. And this talk is going to be mainly about digital humanities well, I guess not necessarily digital humanities, but just sort of more of the humanities style of use of virtual reality and augmented reality. There are lots of other conversations you can have about other topics. And I got some advertising in my slides, which I have hidden the slides. So let me unhide those for you. There we go. Excellent. And this is a series that happens over in Franklin Hall 052, so in the media school. It's hosted by Bill Sherman and the Advanced Viz Lab. And you see we've kind of gone through quite a bit of talks this past semester, and then, or this semester we're in right now, and then we're going to do this again in the springtime as well. And just keep an eye out for media advertising about that. And then coming up is the archaeology training with virtual reality. Yeah, so these are on Wednesdays. So that'll be on April 3rd for that next one. And then we also have a bonus where instead of you listening to us talk, we actually get the equipment all out and spend the entire session using the applications and giving you a chance to really get hands-on and realize that this is not that difficult and it's quite useful. They call these VR expeditions, and the next one's about science education, hosted by Bill Sherman. And yeah, so I should show the rest of the Cyber DH talks. I don't know why it skipped over that. So this series, that's today, the 21st. The 28th is 3D digitization. That's a really, really important talk coming up on next week, March 28th. The reason it's so important is, you guys remember when scanners came out, we could scan documents and digitize documents. Well, now we can digitize objects, and there's lots of ways to do that. So, you know, any object from your car to your favorite action figure to, you know, a historical artifact, you can actually make a 3D object and put it up on the web just like you would a YouTube video. So there's a lot to this, but what's really cool is you can take those objects and put them in virtual reality and augmented reality as well. So that's next week with Tassie and Jeff. All right, let's get into it. So there's a relationship between virtual reality and augmented reality. That's the most reason why I guess we combine these talks is you can think of VR and AR on a spectrum. And this is sort of the academic way of thinking about these technologies. So if you had the real world environment, let's say on the left, and on the right, we did a completely virtual reality or virtual environment, whether that's created with a computer, or maybe it's created with, like if you go to Disney World, they have, it's a real world environment, but it's pretty much a virtual environment, right? They've recreated a fake fantasy space that you're in. It's kind of like a virtual reality in that way. But we're talking about digital virtual reality in my talk today. So if you have a 100% synthetic computer simulated world on the right and reality on the left, then you can blend the two and you get augmented reality. And then you're gonna end up thinking about this in a lot of different ways and maybe being confused when you listen to vendors like, say, Microsoft. They say mixed reality. Well, where the heck does that fit in the spectrum? And they'll give a variety of reasons why they use the term mixed reality, but you can feel the relationship is you're just blending reality and a virtual reality together. And this was defined by this group of researchers in the early 90s. They call it the Milgram's continuum. And even back in the day, they didn't really quite know how to actually put this all together. So they had terms like virtuality, which actually was a company name. So it's been confusing, but what I wanted to make clear was this continuum. They are very much related in the tools that you use. So I can use the same software tool, Unity, to produce augmented reality or virtual reality stuff, you know, apps. The history of augmented reality, I'm going to start with, I'll get to VR later. Started out, of course, you know, the concept of combining like holograms or virtual fake objects started out as a literary sort of conception. And then as time went on, we were able to advance computing to a point kind of in the 60s to build head-mounted displays, so systems you wear on your head that compute extra graphics in the virtual world in front of you, or in the real world in front of you. That's what you're seeing here. It's called the Ultimate Display. That was in University of Utah. And tools came about. So this is a C++ tool that came out in the 90s. This is a little bit before my time. And then Vuforia, that's where I started. Well, actually, I started in Flash, so it would have been more like in, it's not on the timeline, but this was my first augmented reality Hello World application. So if you've ever taken a programming class, you have to do Hello World, which is just getting something running. That was it's made by GE. You could actually blow on the webcam and the wind turbines would spin. So they based it on like the sound coming through the microphone. Anyway, yeah, now we're in an age where we have Pokémon GO and augmented reality is becoming a more household name. So in grad school, I used to talk about it, and you know, holiday breaks, I'd be explaining over and over to my relatives what the heck all this stuff is. And then now they're like, oh, did you see this, video that's like 4 years old? And yeah, I saw that. But people are getting into it is what I'm trying to say. HoloLens has come out, and HoloLens 2 was announced just recently. So that is a headset that I've got here today, HoloLens 1. And you guys can try this today. We're going to spend about maybe 10 minutes at the end, and I can stay later if people want to try these things out. All right, so at the university scale, we're talking about pragmatic ways to approach this, okay? The easiest way for you, from your own unique perspective, to get involved with using VR, let's say, I don't know, what are you studying? Instructional technology. So are you in the Center for Teaching and Learning, or are you a student?
No, I'm a student.
Student, okay, so we have some others here from Center for Teaching and Learning, sorry. So if you're studying instructional technology, you can actually use virtual reality to teach people things. It's actually a big area of research, which is training with virtual reality. So the way you might get started in using virtual reality is, instead of writing your own application, just look at what's out there. So there's now pre-existing applications that have pre-existing, where you don't have to do much other than just get the hardware, put the headset on, and go. And that's what we call type 1 use, which is just finding something out there. If I'm going to teach a person how to operate a forklift, there actually is Forklift Simulator, and it's a VR application where you can drive a variety of different forklifts all in a VR headset. And you can break the building down, and you can knock over stuff, but it's all safe. You're sidestepping the safety with the technology. So that's what's really great about it, is it's a simulated immersive environment. You can use augmented reality to do the same thing. I helped a student, which you'll see later, build a blueprint hologram, so you can actually see how mechanical parts all fit together, just using your cell phone to look at the hologram. So that's what we call type 1, which is finding what's out there and just using it. Easiest way to do it. Type 2, we encourage more and more people that are creative to explore type 2 use cases, where you're not trying to learn how to become a software engineer and write your own applications. What you do here is you find a viewer application, something that already exists, and all it's waiting for is just you to put your own custom content on board. YouTube is a good example of this. You can actually take 360 movies that are meant for a VR headset, upload them to YouTube, and then people can look at those in a VR headset or just on their screen and kind of spin around. There's a thing by Google called Tour Creator. Tassie and Matt Mercer have worked with that, creating a kind of a duplicate to the limestone tour that they give here on campus, just by taking photos of kind of the hot spots in the tour where people actually physically walk around. And then a type 3 use case is where this is what people assume a lot of times that they have to do, which is build your own application, build your own data. And that's engineering. You're going to write your own software at that point. So you can actually break down VR and AR into those 3 types. And we use that terminology quite a bit. Is that a type 2? Is that a type 1? And then it helps us to understand the complexity of how much work is going to be involved for a given idea. So type 1 augmented reality examples. I've got this one here. This is an educational example for the classroom. It's made by the World. I have some IU examples later.
Because it's one thing to read about science, it's quite another to experience. You can place a beautifully detailed landscape right on the table in front of you, and you can explore and interact with it. Students can fly in through the clouds, easily move around a free-flowing river valley. Students can see what it's like if they decide to build a hydro application and the impact of their decision on the environment. This is just so cool.
So the thing about augmented reality is you're blending the real world with the virtual world. And in this case, it's not really using the real world too much, other than just the fact that you have the table and they have this augmentation of this landscape on the table. What it allowed for in this application that they didn't really demonstrate in the videos, you could have multiple students all looking at the same object, and they could share the session, and they could put their fingers in the view, and it would actually, you could see their hands. So it's sort of a shared experience where you're sort of looking at the same miniature vignette or a maquette of the environment. Sort of just a learning exercise. There are really great examples for type 2 for augmented reality. This one is, it's by Trimble. It's called, man, I can't remember the name exactly. It's just the HoloLens extension for Trimble. So Trimble makes a software product called SketchUp. It's a quick, free application you can get. They have a paid version, but it's a free application you can get to design like your house. You know, you can 3D model a house. You can 3D model all kinds of stuff. Google used to actually own this. They bought it from Trimble initially, and then they gave it back to Trimble. But anyway, the point is that if you're a person building out some sort of structure, you know, whether it be a sculpture or maybe, you know, a building, a construction site, you can actually augment your design from SketchUp to the real world using the HoloLens. And I mean, we've got one here. So if you, I think it's called Trimble Connect. That's remembered. I could take and design, say, an interior design for this room. I could have like vines coming down. I could build an art exhibit. Do that all with keyboard and mouse, and then upload it with Trimble Connect to the headset, and then walk in this room and see it here all in front of me. Okay, that's the point, is sort of pre-visualization. Or it could be the art exhibit itself, the augmented reality exhibit. Oh, I forgot to mention, so the HoloLens 2 now can be customized per company for specific ergonomics. So we're seeing here them modifying their platform to work with a hard hat so that you can actually use it in the field, and you're A-OK in terms of OSHA. So this is something I brought today for you to try. Last November, I produced an exhibit to visualize these IQ walls. So this big screen I'm using here is something that our lab integrates for the university. There's a lot of these around on all the 9 campuses at IU. So what's hard to communicate when you have such a large, expensive apparatus to people who don't have one of these that may be interested in getting one is, what is it going to look like? So what I've done is created an exhibit where you can see a miniature of it, and then also a version that's full scale. So you guys can also try this later. This is just a screen recording from my cell phone. This was in Dallas at the supercomputing conference. So these foam core, I don't know, they kind of look like QR codes. They're just pictures, or fiducials is what we would call them, are things that the system can recognize. You can actually use the HoloLens and look at them, and it will pop up, or you could use my Samsung device and have it pop up on the screen. And all we're doing here is just showing what you can do with these IQ walls that we designed. So the bases can kind of move around, and we're having, you know, different arrangements for different purposes. This is more of a creative arrangement for maybe a scientific exhibition, you know. This one would be more like a gallery type setting. And I'm going to fast forward so you can see the full scale. Yeah, we 3D printed out miniatures so people could rearrange them themselves. And then we can do full scale as well. So if I take this, throw it on the ground out here. This is the full scale column right there. So people were walking down the aisles looking at me like, what is that guy looking at? But I could see the full system. So you get the idea. I'm going to leave this to the rest of your imagination. We've got them here if you want to try it. That one took a long time to make. That's a type 3 example. Tassie asked me earlier, how long did that take? That was 90 hours for me to program that and put that together. So it's not easy to do everything. However, if you do pay attention to what's out there in your chosen field, like say instructional technology, there's a lot that people are out in the world are putting out for free or for small fees as apps that you can get and use on these AR, VR systems. Okay, so also at IU, we've got lots of researchers and artists using augmented reality. So this one comes from mechanical engineering. It's just a good example use case. I'm gonna mute it and explain. So the professor came to me, and this is an instructional tool is what we created here. And actually Samantha there, she made this app. She met with me a couple hours a week, and then I helped her learn how to use the tools to build this. This is a type 3 construction. And the students were having a hard time conceptualizing how to assemble these steam engines, that they were learning how to use machinery to, you know, mill parts and use a metal lathe and all of that. So the blueprints themselves became the fiducials or the image targets, and then you look at that with your own cell phone, and then you would see a hologram of what the part looks like. And some of them had some interactive features. I'll fast forward to the end so you can see the full assembly. But anytime you're having a hard time with conceptualizing a 3D shape from a 2D shape, maybe a 2D picture in a textbook, and you want to see the 3D shape or maybe an animation, augmented reality is an accessible tool to do that. As you see, where she's just running an older generation Android device there, and it works fine. Now, our lab doesn't necessarily say that we have full support for mobile development. We know quite a bit about it, but we're not really in the business per se of like helping people write apps. But we'll get you started on a pilot. And then it's like if you wanted to go to the App Store with something, you're going to have to kind of go outside of the university or outside of our group to find the ways to do that. This is Caleb Weintraub. He's a professor in SOAD, and he's a traditional painter. So he worked with me and explained to me this concept of en plein air. It's a French term that means painting in nature, basically. And when you're painting in nature, you set up your canvas as you'd imagine, and you're just looking at your subject matter, and you're kind of having an experience and creating an image of it from your own mind's eye, but with the real subject matter. So he decided, since he's also a digital artist, what if I could look at my computer graphics content that I create in 3D, my virtual environment. So what you're seeing here is his perspective, looking between the canvas and a 3D model that he produced that's floating right next to him. But the HoloLens was a great tool because it's hands-free, right? So Caleb could look to his right and see this sort of arrangement of objects that he created in Cinema 4D, which is just a 3D modeling package. Look back at the canvas, paint a little bit of it, go back and forth. So this is what we call it's en plein air. So it's like you're not necessarily in nature, but you're painting with your subject matter. So very creative use of augmented reality. Also, Hannah Campbell and Heron School of Art up in Indianapolis. She had an expense problem. So she designs furniture. She's now employed in Minnesota working with one of the big manufacturers for furniture up there. And she designed this system that combined wood and 3D printed connectors, but she couldn't afford to print or buy all the pieces. So she built, a fraction of her exhibit for the gallery and then used the HoloLens to augment the rest of the furniture concepts. So that way, at least she could visualize at scale for people that were coming to the gallery to see what she was there to show. So she spent a lot of time learning how to animate. Then I helped her just take her animations and put them in the HoloLens. This wasn't much work for her. This is again a type 3, but she probably spent 20 hours total learning and then implementing and testing and redoing it. And over the course of a semester, 20 hours isn't really that big of a deal. This is a type 3, but we were creating a viewer. So this Dr. Travis Bellacci here on the left, he developed a method for prosthodontics. It's a sort of a little famous project that's happened in the recent years with our lab. And what's nice about Travis is he kind of just says, this should be possible, but he's not really a technical guy in terms of like writing applications. He's a dentist. So he just came and started hand waving in the School of Informatics, said, I should be able to use 3D printers to print prosthetics on people's faces that are, maybe missing their entire lower jaw. So he found a team between our lab and the School of Informatics to build a workflow. And that's what you're seeing here is an application that's printed on his face. So they've got this workflow going great in terms of 3D scanning, digitizing a person's face with the void missing, say they had cancer or something, a portion of their face removed. Then a gaming student actually used ZBrush, which is a gaming production tool, to sculpt the missing portion of their face to print out a prosthetic on the person's face. So they call this a bolus. It contours to the face. And then they could actually take that and send it to a company who could get the colors right to match the skin. But the print they could actually wear and be pretty close to their skin color. So they did this in 24 hours. When they were having to shorten the time was, what if they spent the time to print it and it wasn't quite right and they needed to go back? So they needed to look at it before. So they needed to pre-visualize before they 3D printed it out. So augmented reality is a good tool for that. So what you're seeing here is a student that I worked with named Mark, and he's wearing kind of a fake nose here as a hypothetical case. And the scenario was that Dr. Bellacci would be able to put on a HoloLens and look at his patient from any angle with wearing this sort of, the patient would wear this tracking helmet that Mark designed. And then you would kind of see the prosthetic on their face and they could naturally move and it would be there. So the hard part here was we're using 2 different systems to get that to work. So this was a significant effort for Mark and I, but it was kind of a little breakthrough. What you're going to see here is us testing the latency or the augmented reality. So you see the real 3D printed headset that Mark's got there, and then the augmentation that sort of follows along with it. So. Some pretty interesting work. I just like to highlight that because it's a good story. So moving on to, how you think about the devices, the platforms. So we, with augmented reality, don't have necessarily like systems that you can go check out of the library to like do augmented reality. We consider a lot of the systems you use with augmented reality as bring your own device. Okay, so like Samantha with the Steam engine, she's just using her own personal phone. But you can get away with just using an iPhone or an Android device, iPad. There are more specialized tablets that you can use. You can even use a laptop, okay? As long as it's got a webcam, you can do augmented reality with that. We'll build kiosks that they set up, put buttons in. It's like they were giving away, they're like, put the button inside the little hole here, and on the screen you see your hand holding the button, and it meant student artwork off the button. It was like a marketing exhibit. So, yeah, there's a lot you can do with just your own stuff you already have. And then there are emerging augmented reality hardware platforms coming out. These are the HoloLens 1 and 2. There's Magic Leap, which is not pictured. And others are all sort of competing and biting for time. But right now, the big players like Microsoft, they're building products for what they call enterprise, which is businesses, basically. And not necessarily building everyone, so it's going to be a little bit of time before you can go into Verizon and buy a pair of goggles or glasses that work really well. But it will happen in our lifetimes. There will be early movers with that, and then eventually, somebody like Apple or Microsoft will design something really sleek and nice that catches on, right? So when it comes to the software tools, I like to present what I call learn that word from Tassie. So the way I think of onboarding are tools that you don't need to learn how to be a software engineer to use or learn to be a programmer. So HP Reveal used to be called Erasma. What's cool about there, download it, you use an augmentation right there on your phone and then point it at whatever you like to augment off of, like will actually have the object augment up top. Oh, sorry. And there is also cap for this. Sorry. There we go. Let me again. Yeah.
Everybody was able, so it was a historical deck of cards with pictures of it and popped up.
So I'm teaching a class on informatics, and one of my students really wants to build an app where any restaurant that you go to, you'll be able to just take your phone and just like scan the menu, like bring it over. Items that are known will pop up with either 3D versions of that food or like pictures of the food. And we used HP Reveal to start with, to prototype it. And we did like the Buffalo Wild Wings menu, and we got like a rack of ribs to augment like, right off of the, that's badass. 10 seconds, it was no big deal. So I highly encourage you to look into HP Reveal to try it. Unfortunately, I did get an email from HP saying they're retooling that whole system. So they bought that from Erasma, and now it's being retooled. So I don't know how much longer it'll be available. Key too, also, they have complex tools, but they also have very easy tools to do GPS-based augmented reality. So you're seeing here advertisements for locations. So it's like wayfinding. You can use it for that. It's not the best tool, but these are tools that you can kind of adopt quickly. And then this recent one I just found is called Torch. So this is a company out of Florida. They are they're killing it. What they're doing is letting you use your modern iPhone or Android device that does a type of tracking that doesn't need a picture, right? So you can actually just look around and it'll understand the environment. And what you're seeing here is a Wayfinder app where maybe you walk into an office and you point your phone at this little whiteboard there and it says ready to go, and the airplane flies over to where you're supposed to go first, and then it teaches you where to go in the building. So you can actually map an entire building with your device on Torch without programming, and put little animations, text, whatever you want that will show up today, tomorrow, 5 years from now. And so encourage you to try that out. I think it only works on iPhone right now, and then you have to contact them if you want to try Android. So if you're looking to do a type 3 development where, again, you're building something from the ground up, great, I'd love to help you with that. That's kind of what our lab is around for, is the researchers or artists that can't necessarily get what they need from what's out in the market. They need to build something from the ground up. So we use the base package Unity, and remember that continuum I showed you where we had augmented reality and virtual reality on the same line? You can use this tool to build augmented reality and virtual reality. Okay, it's got a whole host of plugins built into it and some that you can add to it. And I have tons of tutorials now that I've made for it, and they have some on their website too. I think I learned this in a weekend, this software package. I sat down and just had their video tutorials up on a second monitor, and I just used their software there, and I just followed along, and I was like an expert by the end of that week. So it's pretty easy to teach and learn if you stay dedicated with it. Vuforia is a plugin for augmented reality that works on mobile devices. AR Toolkit's another one. The HoloLens has their own plugin. A lot of these you don't have to download. They actually come with the installation of Unity. All right, so I'm an analyst. That's my actual job. And when I have anybody that comes to me and says, I have to build it myself, augmented reality or virtual reality, but I guess I'm speaking only about augmented reality here. If they say, I have to build this because this is the only way I know how to teach this, or this is the only way to make something work, then I say, okay, what exactly is it that the user is going to do? And what we're trying to find out, first of all, is what type of tracking system, augmented reality tracking system, are we going to use? And this looks pretty complex, but what I'm trying to help people understand here is that there are no tools that do all of these types of tracking. When I say tracking, I might have glazed over eyes, like, what are you talking about? The computer has to be aware of the 3D world, the 3D real world, okay? So with an image target, a picture, you can say that this is the anchor, I'll say, that when the phone looks at this, it essentially just says, okay, that's not gonna, but I know I'm moving, so let me redraw the content on the screen so that it looks like I'm actually moving around it in 3D space. Okay, so that's what's happening, is the computer's using this to anchor the 3D content on the real 3D world. So that's how you think about a picture image-based tracking. So marker tracking, 2D image-based, okay? Body tracking, that's pretty self-explanatory. A lot of you have probably used Snapchat, right? You put the face filters on. Some of the phones come with face filters. They're just doing face tracking, okay? Face tracking is a type of software algorithm that recognizes our eyes and our mouth, and then it can actually track the 3D shape. We got some really complex face tracking. I think the first I had a beard with shamrocks in it. That was the first face tracking I ever did. Location-based, we all know about GPS, right? Network, this is like, cell phone trying to figure out based on what cell phone towers are. Beacons, you don't really have to worry about that. Those aren't very common. And then this big new one called area learning. So this is what I'm talking about with like the Torch AR thing with the little airplane flying around the room. My phone, this is a Samsung S9, it can do area learning in that all I have to do is just go slow, and the phone can actually detect the shape of this room based on 2 cameras that are on the back here. You don't necessarily need to know how it works, but I'm just trying to explain that that's another type of tracking. And then it can identify flat surfaces, like we saw with the World Wildlife Foundation one, where it identified the table, and then you press the screen and it created the landscape on the table. That's all it was. It was just a area learning flat surface interface. So what I do when I'm approaching a new project where we have to develop it from the ground up is try to figure out exactly what type of tracking we need first, and then I can help you figure out what tools we can use, because there are like no tools that do all of these, like ever, not yet. There's one last one that showed up here in the bottom left of the screen. I'll move out of the way. And this is something Microsoft and Google and Apple now are starting to compete on. So you've probably heard the term machine learning. computers can now make approximations in their decision making, usually if you give them a picture of something. So this would be like, let me give you a good example. Google had a product called Google Goggles that came with phones. So you could point the phone at like a product and it would come up with the Amazon link so you could buy the product. Basically, it's recognizing people, places, or things, okay, based on just a computer making a machine learning algorithm go through the process of trying to detect what something is. It's very new, but that is a form of augmented reality tracking that has less to do with knowing where things are in the 3D world, but more about what's in the 3D world. So the HoloLens 2, for instance, has this capability. I could put this on, and it silently in the background would say, that's a person, that's a person, that's a person, that's a person, that's a table, that's a floor, okay? And then it's up to the software developer to make use of that information and say, oh, okay, those are people. Maybe later they'll actually say, what's their name? You know, and it would actually pop the person's name up, which probably has privacy problems. You know, we don't necessarily need classes that identify everyone's name all the time, but that's where kind of software capability is heading with augmented reality. This is what SLAM looks like, or area learning looks like. So I say SLAM because that is the name of the algorithm, simultaneous localization and mapping. This is how you can think of area learning though, is I'm looking through the device and it's creating the 3D shape, and all that spider web stuff we're seeing there, that's just the 3D mesh. Okay, that's how computers understand 3D shapes are triangles, sort of interwoven together into a shape. And we can actually even extract that. So I could use the HoloLens to 3D scan this room. So what's that? It's really blocky, and I could, actually, if you guys give me a moment, I can show you. You'll see kind of how not useful it is for a digitization instrument. So what I'm going to do here is bring up a website that is being hosted off the headset that I'm wearing, so you guys can see what I'm seeing. And I'm using gestures to interact with this headset, so it's using hand tracking or body tracking along with. Yeah, it takes practice. The new HoloLens, Tassie, you will like, because it doesn't require specific gestures. It's like if you see something, you just reach out and naturally grab. Yeah, both hands. You can be like Tony Stark. 149. You know, there was a person that came to our lab, Tassie, that I was trying to teach air tap to, was missing this whole part of their finger. So luckily, the HoloLens actually does come with a clicker. So they couldn't do the air tap. Okay. So I somehow mismapped I did a factory reset on this HoloLens, so my login echoes aren't there. So what you're seeing here is what you get out from the HoloLens. Normally I would be able to bring this on a website up to you so you can actually see it, but you get the general shape of something, but not, like, you can't see the colors, you can't see necessarily like the actual details of a person's face. It actually tries to filter people out at this point. Man, that's probably messing with you, sorry. Okay, get back into it. Really? So let me get into virtual reality next. So here at IU, we do have resources for virtual reality. In fact, here in the Wells Library, there are 10 stations up on the 3rd floor in the 3D print lab where you can go log in, and there's a VR headset attached, and you can actually make use of that. You're seeing pictures there from Franklin Hall 052. And this started out as a partnership between our laboratory and the local IT pros that are, like, say, here in the library or other sites, different IU campuses. And we created sort of a workstation that you would see in a computer lab that has a VR system attached to it. And the reason we've done this is because VR systems and software become less expensive and way easier to use. This is what we call a reality station. So not too different than a regular computer workstation. It's a Windows desktop. You can log in with your regular IU credentials, and it comes with an HTC Vive. And they're sparsely around on the different campuses, but they're equipped. And I'll show you a kind of a rundown of where they are and where you can get access to them. They're composed of 30 pre-installed Steam VR applications. Well, what's great is if you're aware of Steam, it's kind of like iTunes, but for video games. You can make your own free account on Steam, and you can buy your own VR games. And you can install them on the stations without special permissions. So you can do that now. If you see a VR game online that you like, you could buy it, come in and log into your Steam account on one of these stations and just run it. There are, of course, Windows applications on these systems, so they can be used for non-VR activities like the Adobe Suite, you know, things like that. So this is a representative lab in Franklin Hall. And currently there's 13 labs open. They vary in terms of open access to closed access depending on where their location is. We have pilot reality stations set up in a few locations as well. So these are like, IU South Bend is trying one out right now, and IU Southeast as well. But here you can see the rundown. If they're classrooms, these are probably only going to be open when the classroom's open for open access. If it's a lab, then you should be able to get in and get access. Like I said, in this building, on the 3rd floor, you can check out the one in the 3D print lab. Let's see, where's that one? 6 seats, yep.
Yeah, and it's really great because it's not in a classroom, it's really open all day. So if you were just like I went and I did a cultural heritage one where we actually had the Titanic. And you could go down a submersible and then like navigate around the Titanic.
Right. There are some really amazing applications like Google Earth. I'm going to get into some of the examples of it, but probably my favorite is Google Earth VR because you can just fly around the Earth and just go anywhere you want. Up on top of a mountain, bottom of the ocean. So this you've seen before. I was talking about augmented reality in 3 different types. VR is exactly the same use. You have type 1, 2, and 3. You can find stuff that's already out there. You can add things to VR yourself, or you can make your own applications. All of this is available to you, however kind of deep into virtual reality you want to get. Here's some examples. So this is a type 1 use. So this is an anthropology class at IUPUI, and they were studying in Oaxaca, Mexico, the Monte Alban UNESCO World Heritage Site. And Alex Elvis Badillo was also on a project where they were using a drone to 3D scan that entire site, what it looks like nowadays. But the project hadn't finished their photogrammetry work yet, and he wanted to show his students, because he was actually leaving IU to another university, but he wanted to at least show them before he left. So we used Google Earth to allow them to fly around in the site, and he was able to go between each student and kind of have a conversation on what they're looking at and explain as they explored with their own autonomy. He could just pop in and see what they were looking at and then sort of give them some input. Interior space and furniture design. So this is John Rasick in the SOAD department, and he's been using virtual reality for, I don't know, for quite a while now. I remember helping him when the Oculus Rift first came out in 2013 with his students. So they design the interiors of buildings, so the furniture layout, the walls, you know, paint, the fixtures, and they do this all in a package called Revit. And what's really tricky about Revit is it's a good designer package, but it's hard to get your stuff out of Revit and into some other software like, say, Unity or, you know, some other location that you might want to use it for, say, virtual reality or augmented reality. Well, we found a package called Prospect Pro. So if you were designing something in 3D, you could actually just put on a VR headset, and Prospect Pro most likely will run it so you can actually see it in VR if it wasn't already in VR. I'll talk a little bit more about Prospect a little bit later. This is a type 3, but it's a really great project that I like to highlight for virtual reality. So right across the street, across West Street in Indianapolis, the ICTC building where I work, there's this church called the Bethel Heritage AMC Church, And it's a historic African-American church. It's the oldest known African-American church in Indiana, I think. Definitely in Indianapolis. But the congregation could not pay for the building anymore. It's amazing looking building on the inside. Hand-hewn parts and then all hand-tooled parts of the woodworking, the painting, and everything. And the building was leaking. It was just really hard to maintain. And the building looked like this tiny, nice, like historic building in the midst of all these massive, downtown city buildings, right? So they moved their congregation outside of Indianapolis. It was a hard choice for them. So Professor Zeb Wood and Albert William worked with their students to 3D scan the building with LiDAR. And then you can see on the left here, these like sort of spider web lines. This is the mesh that they created based on that 3D scan. And they recreated the entire church, colors, the lighting, everything. And the congregation was able to put on VR headsets and go back to the site, right? A couple of them started crying when they saw it again. It's like, oh my gosh, I used to sit right there all the time. So really cool concept for restoration or digital preservation, I guess, is the way you call it. And this is right now available on that URL. And you can download a version of it and run in VR. You can actually do a walkthrough on the web if you wanted to go to check it out right now. And so far at the Reality Labs, we've had, I didn't update this slide, but at the time when I made it, there were 77 new applications created. It's probably double that now. So as I teach classes, I have students build their own applications, and man, it seems like they're producing a new one like every couple weeks. So as folks learn to develop VR, I think it's kind of fun to watch what they do. I have a student that's, he's really into like dark comedy video games. And he's building one where it's like a escape room kind of thing, where you have a puppy in a cage, and it's like a cartoon puppy. Okay. So you have to hurry up and get the cage unlocked with a puzzle, and there's a piano dangling above you. And then if you don't get it, he actually has a giant piece of foam that's going to unlatch, and you'll feel the foam hit you as the virtual piano hits you. Yeah. So there's also an VR arcades, this sort of dark humor happening nowadays. It's sort of a small trend in video gaming with virtual reality. There's one called Richie's Plank, and I'll play a video of it real quick. I think I've got it. I think I've got it here. Yeah, we could try it. So you put a real 2x4 down on the ground, and I'm not going to turn the volume up because this is Jacksepticeye. He just curses the whole time. But you go up an elevator, and you're like sort of a tightrope situation, but it's a plank. It's a plank hanging off the side of the building. Okay, so there's various challenges. Yeah, and he's just sort of jumping off the building, but yeah, there you go. Yeah. So like you hear the term immersion, and a lot of people will have that going one ear out the other, but when you're in a VR headset and it's a good example of immersion, like it's well designed, you're gonna feel all of the animal sensations you would if you're standing on the edge of a building. Because even if you logically know you're not actually gonna fall off the side of that building, there are parts of your psyche that's telling you, hey, don't take another step forward because you're gonna die. Their survival instincts do kick in. And I used to hear people say that in academic research, but then I've been in lots of VR experiences where my animal instincts do kick in, and it's pretty interesting to realize how segmented we are as far as how our brains work, how partially in control we are. So moving on here, this is what we call our advanced facility. So this lab is in ICTC 403. We call it the NEXT lab. New Emerging Experimental Technology Labs. It's concerning ultra high resolution, virtual reality, and augmented reality as far as the tools that you'll find in that room. And what's really great about this slide is I have an actual 3D scan of the room that I can show you. So this type of room is being duplicated right now in the Innovation Center on this campus. So you will all have the ability to request access or come use these facilities in the near future. What you're seeing here is our reconfigurable IQ wall. That's all 9 columns together, or is it 8? 8 columns together, 60 or 32 screens all put together into 15,360 pixels wide. And you just log into that with your IU login and you can have access to this giant screen. It can do virtual reality as well. We have VR reality stations here that are mobile. They're on wheels, so you can actually set up a rig in the room. This would be a room for people wanting to push the limits of virtual reality and augmented reality. We have a facility over here called the Reality Stage. This is a truss system that allows you to mount equipment around your user. So we have fans all set up in here and a heat lamp, and this could be rearranged for all different scenarios. If you're training a person that needs to feel wind, feel heat, maybe a firefighter, maybe someone that's working in the front lines of some application and you need equipment there, or maybe you need to mount them because they're a paraplegic, right? And you're teaching them how to do therapy through virtual reality, how to walk again. We can sort of entertain the idea of building applications for that or allowing you to have access to do that. But with these fans here, we're actually able to simulate what it's like to feel the breeze. And that's based on a device that I made, started kind of in the lab about 6 years ago, and I've been just iterating upon. That's what the Reality Stage looks like there in action. I'm currently working on actually mounting a couple Kinect sensors in there to do real-time capture of the shape of a person's body. There's a tool called Depth Kit. And Tassie, I don't think you've ever seen this, but I'm starting to look into this pretty seriously. So it's sort of a digitization tool, but it's meant for use in filmmaking. Okay, so you set up a Kinect and you can actually capture, which it'll show you a demo here in a second. It's loading. Oh, probably not because I'm in Edge. Let me open Chrome. I mean, it'll be like what you'll see here, where it's like just like your front, like it won't capture like the back of you. Yeah. So like if I move the mouse here, me too, yeah. And I have folks that don't necessarily want to learn animation and the whole traditional process of like making an avatar and like being a game developer per se. But if you could just record people like video and have them three-dimensionally show up, you can do a lot of things. So this works for, museum installations. If you're like in front of a sculpture, you could actually record a person with a Kinect talking about the sculpture and pointing at different parts of it, and then that for your visitors later on with a tool like this. So yeah, we tried this and it worked pretty well. So works in Unity right away. Moving on here. Yeah. I'm sorry? Yeah, the Kinect. Yeah. Yeah, we were using the Kinect 2. Yeah, works really well. This is another image of the reconfigurable IQ wall in its largest state that we've ever put it in. And that's Hoagie Carmichael, is that right? And that's a bronze statue that's, I don't know where that's at. Where? It's actually 400 yards that way. 400 yards that way. So to the south here. That is a very high resolution photograph, but we could actually put a 360 rendering on it. You can kind of spin the screen around. Very cool display, very cool tool. We've got it split in half into 2 smaller designs that resemble this shape here currently. But as you stop by IUPUI in the future, you may come by this room and it'll be different every time. It's what's nice about having a screen that can kind of change its shape. We share our pipelines on both systems. So the Reality Stage or Reality Station themselves and run, say, a virtual hot air balloon. You can run the same thing right here, So when you create a project in Unity, you can do a lot of things with it, with a little bit of adaptation to kind of move between different systems. All right, so I want to talk about resources. I've kind of just shown a lot of Flash, but I want you guys to consider these as something you can use. So type 2 resources, these are things that you create content for to repurpose for your own desires, okay? So Tour Creator is a tool that's hosted on the web by Google, where you can take 360 photographs with what we call media capture, immersive media capture tools like these 360 cameras, like the Ricoh Theta. A few $100s to get one of these. This one's about $800. This one's about $3,500. We've got one of these in our lab. We've got one of these. We've got several of these. So you really had to use it, you can talk to us. We don't necessarily run a media checkout or anything like that. There, he's got a Ricoh Theta right there. Can you take a picture real quick so they can see how fast it is? So Matthew is turning on the Theta. What's cool is that thing also broadcasts Wi-Fi. So you can use your cell phone, you hide around the corner, and say, take a picture, and you hear it chirp.
Yeah, so the worst part about a Theta is obviously you're in every picture because it's 360. So it's the only justified use for a selfie stick.
Yeah, right. What's great is there's a tool called Captivate that you can get right now on IUware. And you can take these 360 photos. Let's say you're showing a person around a space. You're going to create a tour for an instructional thing to showcase to someone else. And you can go and Captivate, and you can actually author like information. You can tag text, tag pictures, just like you would in Tour Creator on the web. So like there are really interesting ways where there's no programming involved to create tours either on the web or as instructional content. And they have different features. So if you're into building virtual tours, consider trying out both of these. Google Poly is where you would host your tour if you use Tour Creator. Google Poly is like YouTube for 3D models. There's another tool out there called Sketchfab that does kind of the same thing, but these two interface because they're both Google G Suite products. YouTube is also a G Suite service, so you can actually take 360 video with these and put that up onto YouTube. It can be 3D 360, or it could be just flat monoscopic or just a bubble around you video. And those work on YouTube. And you can actually run YouTube VR in the HTC Vives upstairs in the 3D print lab and watch your content. Now, if you have 3D data, Prospect Pro is what I'd like you to look at, because this is a way to just quickly take your 3D data and take a look at it. And it's also a shared concept. So one example of this being used was up in Indianapolis. We had a bunch of students in mechanical engineering technology redesign an interior space for a monastery that's in Indianapolis. So the monks gave sort of the architectural access they needed to reconstruct it, and then every student had access to the same building model, and they redesigned the interiors, and then they, just like it was their client in a real world architecture firm. So the monks came in at the end of the semester, were able to put VR headsets on with the students, and they gave a virtual tour of their design. And what's great about this design, so we have a person here labeled as Casey. It looks like Casey is sort of leading the tour here. These are other people, Tyler, Sarah, and Jeff, and they're watching this. If they wander away, Casey can actually hit gather, and they'll all get kind of zapped right over to where Casey is, and then, you know, hey, look at this, look at that. Really interesting way that spatial technologies now becomes collaborative, and we're hoping this just continues to snowball and become accessible, because that is the gold standard for this stuff, is if you can go to class from home or actually in the building, put on a headset, and you're all together, and the instructor creates or curates the environment like they would a PowerPoint presentation. You know, that's where it needs to get in terms of virtual reality in education. How cool would it be if you went to class in a VR headset? I think it'd be really cool. All right. So there is creative ecosystems in VR, like the Adobe Suite is a creative ecosystem. You can use Photoshop to do 2D art. You can use After Effects to do visual effects. You can use Premiere to do video, and they all can kind of work together. Starting to have that kind of stuff sprout up. So you can go in a VR headset and Tilt Brush, which is a Google product. It's like $30. You can paint basically just with your hand, and it's really cool. It's a lot of fun, actually. And I have a student I'm working with now where she's designing a card game that's based on a cemetery. So every card is another gravestone, and she's doing all the gravestones all in Tilt Brush. And some of the gravestones will be booby-trapped, but you're a grave robber. And as you which grave you're gonna rob by reading the epitaphs, thinking about what they might have been buried with, jewelry, you know, if you're Frankenstein, you're going after brains or body parts or whatever. She's also drawing in the booby trap explosions. So she's using this tool to design her artwork for her augmented reality application. Okay, and then what's cool is then those sketches can be saved up on Google Poly. And this is really cool. Blocks is for designing simple 3D shapes. You see this little rocket ship, this little space person, the planets, the terrain, it's for creating 3D models. If you're not a 3D modeler, get into blocks. You'll learn about 3D modeling because you're just using your hands. It's like a toy, but you can actually create things with it. And then Microsoft has one called Maquette that sort of does both of the features of both of these. This one's in beta, and it just continually gets updated with new features. And then you can take whatever you make in VR and upload them to Poly, and they become a link that you can look at on your mobile device, your tablet, your laptop. You can send it to your parents. They can take a look at it, whatever you want. But it also works in Unity. So you can actually download Poly Toolkit into Unity, and then you can just drag into Unity whatever you made in Tilt Brush or blocks. So it's just like little interplay between using VR as a creation medium. I think that's really awesome. I can't wait till I can edit video in VR and start like, just look at all my files, play a little bit of it, drag one over here, drag one over there. That'll happen. All right, these are resources I created for you. I spent a lot of time on this, and this is for anybody at IU. You can even share this outside IU, actually. Our YouTube page is right here, the AVL tube. And I have tools or tutorials here that, like I was just showing you, Tilt Brush. I have tutorials on how to even use Tilt Brush. I have tutorials on how to upload your stuff from Tilt Brush to Poly, how to deal with the interfaces, like how do you actually click the buttons, like where stuff is. I've got tutorials on how to even use Unity. If you wanted to just a blind introduction to it, like I've never touched the software, what is it? How to use Poly Toolkit. So that's stuff from Google Poly to Unity to build reality, virtual reality. Margaret Dolinsky is a professor on campus that teaches art. She's been teaching fine art into virtual reality for years, like way before I got into this stuff. And I showed her this, and she was actually quite excited about this because now her students could work on a piece in VR and get a sense for the interface and what it's like to have scale and be around your art in a spatial environment, upload it, and then she can grade them just by on her cell phone or something and look at it as a URL. Really exciting. And then I've even got complex tutorials here that teach you how to program in Unity and how to do Vuforia augmented reality and scripting, handset input, you know. So to your heart's desire, you can go as deep into this stuff as you want to. All right, that's my contact information. And then I want to kind of flip this over and do some demos. And I've got a playlist of videos I'm going to play. But for those that are watching online, I think we're going to disconnect because it's 5 o'clock now. But any questions before I disconnect? Let me see if I can get the chat open. Any questions in the room?
Can you import a tour from Google Poly into Unity?
I tried. It doesn't work. I know. So the question was, can you import a tour creator tour into Unity from Google Poly? Is that right?
Yes. So our limestone tour is at the moment limited because tour has also only been out for a little bit. We wanted to add some extra features.
Right.
And so we thought maybe also give a better, it's downsample the resolution.
I'll bring it up.
And so I want to do the plank view.
Okay. So Tassie wants to do the planks.
Y'all can do it.
You're right. I'm going to bring your tour up here. Oh, they have? Yeah, maybe people online haven't seen it. My class is called Experiential Innovation. It's all about, oh, I'm bad. My bad.
So like, could you do like pieces of like merchandise and then like them in a space? Or?
What interests me is I'm an interior design major, so like when you're talking about like going to the room and like seeing like all the furniture place, like that was
Yeah, or you could show a client and be like, this is what happened. Or this is what happened.
so you have to have like the some do that then or like I know
So there's stuff you can do on your phone and you can stick it in a Google Card, which is like a $20.
Yep.
But so Oculus now has Oculus Go, which is a portable headset that doesn't. It's
got its own processor. And so you just, and those are what, $200? They're really like, you know, like if you were a professional like that would really have something.
Yeah, these are
So as a
$199.
This microphone, and then once you put it in VR mode, you'll see the two eyes, and you slip it into like a cardboard or a headset, so that, and then the two, because it has the two eyes, it's slightly offset, how it simulates.
So this is like examples of what people have made on Poly. I mean, there's nothing here that's like going to be like steel case, you know, catalog quality, but like if you need a typewriter, you can get like a stand-in, you know. I like Google Poly also when I'm teaching and learning. If I'm using Unity, I can install that toolkit and I just search for stuff. It's like, oh, I need a cactus because that makes sense for this, whatever I'm doing. So I just find a cactus. And you just drag and drop it. So it's starting to be commoditized doing this kind of stuff. For a long time, it used to be like real specialized, but not so much anymore. Some people will say, I don't know 3D, so I don't want to touch it. I just try to, you know, help people to realize it's not that scary. It's not that hard to do. Yep. So Sketchfab. Let me show you also something maybe get you excited about Unity. Let me search photogrammetry on here real quick. So if you come to the talk next week about digitization with Tassie, they're going to talk about this concept called photogrammetry, and you can find just a really nice example. There we go. It'll keep bringing in detail. So this was all generated from someone taking photos. This looks like one of Bernie's projects, isn't it? I've only been in this environment. So this was all generated by someone taking lots of photographs and processing it through this esoteric software called PhotoScan that makes a 3D model. And that's the way that's your take-home message. And what's cool about photogrammetry is you're now digitizing the real world. So when you are creating a virtual world, you can do things like this. So let me go on YouTube. And if I had more time, I'd download it and show you guys in Unity. But it's called Book of the Dead. I don't know the backstory on why they call it Book of the Dead, but this is a virtual environment created all in photogrammetry, but it's available free in Unity for you to explore and learn how they built it. This is all in Unity. Ed, this is what I was going to show you earlier. So the company that provided the assets, the photogrammetry assets, is called Quixel Megascans, Q-U-I-X-E-L, Megascans. This is a Hollywood type production company that, I mean, their stuff's like, you're going to see it in movies that have a lot of CGI in it, but you can actually get access to it for a subscription fee that's not that unreasonable. I'm going to go to their library if I can find it. Bridge. Yeah, here it is. So like they have biomes. So like if you're gonna build an environment that needs basically that type of biome, the sandstone biome, you can go in there and they just have like an enumeration of assets that you buy points per month, and then you can download assets per month to use. So like this was probably a real rock somewhere, and they just took lots of photos of it and photogrammetrized it, and then you can sort of embed that in a lot of the shared aesthetics, and then your environment starts to look like what we were just looking at, like of that high of quality. Any questions? Anybody want to try this stuff? Yeah? You want to try it? Okay.
The next lab. I first saw that on Redfin, the realty search. So you can sort of see and walk through the house and you can see the dog. I'm wondering, is there anything, would it be possible to sort of have an environment such as that and then be able to insert objects and sort of around the scene?
Oh yeah.
Yeah.
Yeah. So the walk around of the building, that 3D scan, that's just an asset. That's like one 3D asset, and you can generate that in a variety of ways. We use a product called the Matterport, and that is a company that hosts your stuff up on the cloud. That's what we were looking at, was just a website that they're hosting, and you can actually pay them to get that data back out of there as just the raw data. And then it's a 3D asset that you could put in your own authoring package, like say Unity. And I've done this with one of the buildings on campus. We scan and we put it in there. And then once it's in that environment, you can then put other objects in it, even, tilt brush assets or, other objects. And you're asking, can you move things around? I'm still talking about authoring your own software, I guess. So I'm not sure. I'm not that aware of, I guess Prospect Pro would do it. Yeah. So yeah, in Prospect, you can load a series of things, and I think you have some interactive capabilities where you could move things around. I'd have to get back to you on that one, actually.
So you just asked the same question that Michael McRobbie asked, the president of So we digitized the Ontology Lab, and it's drawers.
Oh, that's right. That's
and
right.
McRobbie wanted to know if you could pull out the drawers
Right.
to look at the bones. We had a bunch of stuff that was on top of the walls, and you could sort of see it in 3D. We wanted to be able to pull out all the drawers.
I'll bring that up here. Yeah, sorry, I may not be following exactly what you were asking, but Tassie's right. That is hard. Yeah. PS components. Forgot to put IU in there. So let's go. So this is paleo. Yeah, and Elizabeth recently updated this. You see how it spans an IQ wall nicely now. Yeah. No, I just spelled it wrong.
Oh, I just said you passed. Yeah. So it starts off with this Dallas house view, right? Which is why real estate people, if you're buying a house,
right?
Like, oh, and this is also you're resigning, and then zoom in.
So for those online, the question was, when you're looking at the 3D environment like this that was digitized, can you move the assets around in the environment? And if it's digitized all as one thing, no, you can't. If you digitize them as multiple objects and then put them together, curate them together, then potentially, yes, you could them to be moved. That's significantly more effort to digitize one thing at a time. Okay. I didn't realize IU had so many fossils, by the way. I was, and some of them are micro, like grains of sand. So, all right. So the first augmented reality in the room, I'm going to disconnect from my microphone here. So thanks for everyone online. Let me check if there's any last questions. There is something. Oh, no. Okay.